Hello everybody, Dr. Metzger with CS202 Computer Science 2, and we are going to talk about overloaded operators. So in the last lecture we were talking about having two objects, say foo and bar, and we wanted to use them in an expression. We wanted to be able to multiply a foo times a bar and be able to print that out with cout. So we said that the compiler is going to use one of two overloaded operators. First, it's going to look for a member function of foo called operator star that takes bar for the right hand side of this expression. Or it's going to look for a global overloaded operator called operator star that takes a foo as the left hand side and a bar as the right hand side. So this is argument number 1, argument number 2. And in the member function form, the left hand side is the object the function is called on. So if we had bb times ff, it would look for a bar : operator star with foo as the right hand side. All right, so the order does matter. So let's say that we've written a class called myInt that acts pretty much like an integer, and it has a constructor that takes an integer, and we would like the following code to work. Let's say we declare an a is value 13 and b is value 2. So what's going to happen here is the compiler is going to look for a myInt that takes an operator plus, or it's going to look for a global function called operator plus that takes myInt as two parameters, left hand side and right hand side. So as an aside, let's talk about automatic conversion. So let's just say that we have a function called foo that takes myInt as a parameter, but we want to call it with a number 12. Well, what will happen is that C++ is going to convert the parameter if there's a constructor that takes the given type. So it will look to see if myInt can take an integer as a constructor argument. And what that means is that if we implement the overloaded operator from the previous slide, then we can even write cout a plus 2 and print a new line. So the compiler will look for an operator plus, taking a myInt as a left hand side and an int as a right hand side, or it will check to see if myInt : operator plus takes an int, which we did not write, but it will realize that it can also take the int and convert it to a myInt, which then we can use our built-in, our overloaded operator on the class. So there's a complication though. What if we write 2 plus a? Well, what's going to happen is the compiler is going to look for an int that takes an operator plus. However, automatic conversion only works for the second one because the function int.operator plus doesn't exist. So we have a following guideline. If you're going to overload an arithmetic operator, they normally should be free functions because the member function version cannot do conversions of the first parameter. So let's take a look at an example. So we would have to write myInt operator plus that takes an int as a left hand side and a const myInt as a right hand side, and therefore we can construct our integer using the integer value and that we pass in as the left hand side, and we can then call the right hand side version of our function. So let's talk about assignment. If we have an expression a equals b equals 1, what is actually happening there? Well, let's notice two things. First of all, if you have multiple assignments, they are evaluated from right to left. Now, we think that this is unusual because assignment therefore is not associative. In other words, b equals 1 is, if you were to apply a equals b, what does that really mean when you're doing it over here? It's kind of confusing because we know that addition is associative. That means if you have a plus b in parentheses plus c, it's the same result as a plus b plus c. But that's not true for assignment. So what this next expression, A equals B equals C, means we're going to put C into B, and then we're going to put B into A. So what happens if we put parentheses around that, try to force the issue? Well, in C++, when you have built-in types such as an int, it will actually work. It will put B into A, and then it will put C into A. Now, because of that, there's really no reason anybody would actually do this. So if you see code like this, it should raise a red flag. Now, when we overload an assignment statement, we need to figure out what the equals operator should return. Similarly, what is a plus equals operator going to return? And that means we have to understand that the object that's being assigned to has to be returned. And in fact, that return value must be usable to assign to again, which would change the object. Therefore, we are going to use the this pointer as a tool. So when you're inside a member function, we're going to use the C++ keyword this, which is a pointer to the object that called the member function. So this is a way of referring to the current object, and we're going to dereference the this pointer in order to do that. Now, you could also refer to member variables using the arrow operator, but that's unnecessary since, say, _x already refers to the member variable. So generally, if you're doing this, it means you're probably not doing something correctly. Now, this pointer is an implicit parameter to the member function. You don't normally see it, but it's the first parameter that gets passed in. Now, the const that we're going to put at the end of a member function definition is going to indicate that it doesn't change the object that is describing the this pointer. Now, I would encourage you, go out and try different experiments using this so you get a feel for what it does. But when we overload an assignment operator, we have to make sure that these are member functions. We cannot write a global function to do this operation. So they're always going to look something like this. We return a reference to foo. We have our foo : operator equals, and we're going to take a const foo reference to the right hand side. And so we'll do our copying, and then we're going to return asterisk this, star this. Now, if you write operators like plus equals or divided equals, they're going to look the same way. All right, and the reason why we don't have const at the end is because we are going to be modifying the object. And secondly, we have to make sure that this is a modifiable return value as well, which is why we return star this. So which overloaded operator should you implement? Now, remember, there are two choices. We have the global function or a member function of the class of the left-hand side. So which one do we pick? Well, here are some guidelines to help you. The assignment operators, like equals, plus equals, star equals, etc., have to be member functions. And they should always return star this. For example, if we had a rational number, notice the return type is a reference to the object, and we return star this. Otherwise, you should usually prefer the global version, because this will allow for automatic conversion of the operand on the left-hand side. For example, if we had defined a rational s that takes 1, 2, in other words, a rational is a number that has a numerator and a denominator, then we can say cout 2 plus s. Now, this is only going to work if operator plus is the global version, because if it is a member function of rational, it isn't found. The compiler is going to look for int.operator plus rational, which does not exist. So the appropriate way to do that, again, is define this as a global version, and if you're writing assignment operators, define those as member functions. So those are some good guidelines, although you will see some built-in versions of you'll see member functions used for regular arithmetic operations as well. Okay, so let's apply the dry principle. So what happens if you have an operator plus and an operator's plus equals? Well, we want to make sure that we don't repeat ourselves. So one way that we can avoid that, repeating this extra code, is to write the plus equals operator in terms of the plus operator. And this will allow us to write code that looks like this. So start of this plus right hand side, it'll call this function. And then we have an assignment operator, which then can copy the result that this returns into into our instance. And then finally we can return a reference to ourselves. So this is the application of the dry principle. All right, so quick quiz for you. Why should the parameter for foo : operator plus be a reference to const or pass by value? Why should you write operators in terms of other operators? And what is the difference in syntax between a global overloaded operator and a member overloaded operator? Well, that's all we have for this lesson, and I hope you have a good day. Adios.